Are you struggling with trigonometry, angles of elevation and depression? Well, this is the video for you. What we're going to be discussing is what it means, the angle of elevation and depression. Hey guys, I'm Mr. Hing. Let's get into it. So, when we talk about angles of elevation and depression, we are talking about the angle formed between the line of sight and the horizontal. Now, what is that? So, for example, over here, look, these are a pair of eyes. And for example, if I'm referring to this line over here, that is what it means by the line of sight. It's the line from here that and the way that we are looking, or what object we are looking at, would be over here, for instance, and this would be our line of sight. Okay, that is what it means, and it's the angle formed between this line and the imaginary horizontal, so this line over here. And in this case, because we are going from a horizontal upwards from the line of sight, pretend these are my pair of eyes, and I'm going up and I'm looking towards an object, and they want to know what is this angle. Because it's going up from the horizontal, it will be the angle of elevation. And similarly, the other way around, if I am going from this point over here downwards from the horizontal, this would therefore become my angle of depression. Okay, so a few things that we need to look at before we get stuck into it. We need to remember something, guys, that we've already learned. It is what? It is the soccer toa. So we remember that by saying S standing for sine, okay, which refers to opposite over adjacent, the cos meaning adjacent over hypotenuse, and T standing for tan, meaning opposite over adjacent. Let's go and quickly revise that over here. So if I have this triangle I am working with, if I am saying, okay, I want to know what is the sine of theta. So remember, we look at our specific angle, which is theta over here. So the sine of theta, this angle, definitely not this angle, the sine of theta is going to be from this point, my opposite, and in this case, my opposite is going to be from this side, my opposite is going to be 4, and then adjacent is going to be my 5. So the answer would be 4 over 5. Okay, good. For cos, what is going to happen is my cos of theta is now going to be adjacent, so my 3 over the hypotenuse, adjacent over hypotenuse, which is going to be 3 over 5. And lastly, tan is going to be, or tan of theta, it's going to be opposite. So it's going to be 4. Sorry, this should be the other way around. Let me erase that while I was prepping. So it should be 4, and then it's going to be 4 over, and then my adjacent is obviously 3. All right. Now we're going to use this. That was just a quick recap. We're going to use this knowledge on when and where do we put adjacent and hypotenuse and opposite. And we're going to use all of that knowledge and use it in angles of elevation. So firstly, what is angle of elevation? Well, I briefly explained it, and I want to use 2 examples. Example number 1, you can see that this is the line of sight from here, and we're going up. We're looking to point C, or the top of the light, or the light pole, or the lamp pole, I don't know what you want to call it. And then the horizontal will be over here, and this would therefore become your angle of elevation, because it's going from horizontal, and we are going up above the horizontal, and therefore it's called the angle of elevation. Over here in example number 2, very similarly, you'll see there's a building. It's going from this point over here to the top of the building. You'll see that there's a right angle over here, and again from a horizontal, it's asked, the angle would therefore be considered the angle of elevation. Let's have a look at what happens with angle of depression. So say, for example, there's a person at the top of the building, and they're asking for the angle of depression. So now, for example, they will specify that this person is looking at a specific, maybe a soccer ball or rugby ball, and that would be the line of sight, okay? And this over here would be our new, or another horizontal. And so it's from this horizontal down to the line of sight, and the angle formed there would be therefore an angle of depression. Okay, I hope you can see that. Now let's do some questions. Okay, so I'm just gonna zoom out a little bit here. So let's have a go. Let's read together. John flew his kite 15 meters above the ground. The angle of elevation is 30 degrees. What is the length of the kite's string? Sorry, I didn't mean to put is there. Now, guys, it's important to note that this question did not come with a diagram. I drew this diagram, so sometimes you'll have to, can either think of it, but I would suggest actually just drawing a quick diagram so that you actually know what you're dealing with. So I'm just going to take these guys away because I actually drew these. And what you'll see here is I actually drew in the story, what they were saying. So you'll see that they said John flew his kite 15 meters above ground. So this would therefore be 15 meters. And the angle of elevation is 30. So this would be 30 degrees. And it's asking what is the length of the kite string. So if you are flying a kite with the string over here, they are asking for this. So maybe we can call it X like that. So let's have a look and see how am I going to use trigonometry. Oh yes, I forgot to say a very important part is that this over here, the horizontal and the line going directly up would therefore cause or result in a 90-degree angle, and therefore we can use trigonometry. So let's have a look and see how are we going to use trigonometry to determine the length of the string. Pretend like this is the length of the string of the kite. Okay, let's go for it. So we have 30 degrees, we have 15 meters, and we have our unknown. So if we are going to use 30 degrees, so we use 30 degrees equals, and the thing that we have is we have the 15 meters. So this would therefore be the opposite in trigonometry. So that would be opposite, and we are wanting to find out the hypotenuse, the hype. So guys, what do we use when we want to use opposite and hypotenuse? We're going to use the sine of the 30 degrees, because remember, sine of 30, remember or sine is for so it's going to be the opposite over adjacent. So opposite over hypotenuse. So therefore this will become sine of the 30 is equal to 15 over the x. Okay, and now we want to determine what this is. So we need to apply our rules that we know. So how are we going to get the x alone? Well, firstly, we're going to multiply both sides by x. So we're going to times this by x. So we're going to times this by x. And this would cancel out. So our new line would be x sine 30 equals 15. But remember, we want to solve what x is. So we're going to divide this by sine of 30. And we must do the same to the other side. Divide by sine of 30. Those will cancel, and we'll be left with x is equal to 15 over sine of 30. You put that in your calculator, and you'll get 30 meters. Okay, so that is how we do that question, guys. Let's have a look at the next one, question number 2. So in this case, they gave us a diagram, which is amazing. Let's read the question. So it says, a radio pole is 36 meters tall. A cable holding it to the ground has an angle of elevation of 36 degrees. We can see that there. Find the cable length. So they are wanting us once again to determine this length over here. So let's go and do that. So if I have my degrees or my angle, I have what is known as, so this again would obviously be our right angle. This would be our opposite, and this would be what, guys? Our hypotenuse. Hypotenuse. So we are going to therefore use, if we use our SOHCAHTOA rule, what are we going to use to determine our hypotenuse? Well, we have opposite, and therefore we want hypotenuse. So we're going to use opposite and hypotenuse. So therefore we must use the sine of 36. So we're going to say sine of 36 degrees is going to equal, my opposite is 36, and then it's going to be over the hypotenuse, which is x. So we're going to do the same thing that we did over here. Let's go and implement that. So remember, we want to get x alone. So how are we going to bring x or get rid of the x at the bottom? First, we must multiply each side by x. Multiply by x, because that will cancel. And whatever you do to the one side, you do to the other side. So let's simplify that. It would become x sine 36 is equal to 36. Now remember, we don't want this over here. So how are we going to get rid of that? We must divide by sine of 36. Do the same on this side. This will cancel. So we're just going to get x is equal to 36 over sine of 36. Put that in your calculator, and we are going to get 61,2 468 blah blah blah. So let's pretend the question said round off to 2 decimal places. So we'd round off and we'd say, okay, therefore it's 61,25 meters, because that's how you would round off. This is a 6, so it would affect that 4, and it would become 61,25 meters. Okay, guys, if you are a little bit confused, don't be afraid to rewind and just go ahead and watch what I said. Okay. Right, last question for the day, guys. A ship drops an anchor. It is 200 meters in length. So you can see that they gave us a diagram, which is nice. It is 200 meters in length as it sits with an angle of depression this time from the ship of 50 degrees. So the 200 meter anchor length, right? And then the angle of depression, so from the sea level down to the line of sight, is going to be 50 degrees. And remember, it's an angle of depression. And then it's asking, calculate the depth of the ocean floor. So we know that the anchor has reached it's gone all the way to the bottom of the seabed. And if we want to know the depth of the sea or the ocean from the level of the sea down to the seabed, we can just calculate this length over here, which is considered x. So let's go ahead and do that. So what we're going to discover, or what we're going to investigate, is if we are using our 50 degrees over here, we have a 200, which is known as this is going to be our hypotenuse, because this is the 90 degree. And then this over here is going to be our opposite. So if we have a look at our SOHCAHTOA, we're going to want to be including opposite, so O, and hypotenuse. So again, we are going to be looking at our sine over there. All right. So let's go ahead and do that. So we're going to say sine of 50 degrees. The sine of 50 degrees is therefore going to give me opposite, my x, over my hypotenuse. And I know my hypotenuse as 200. So now this one's a bit easier. We just need to get rid of the 200 to get x alone. So we're going to multiply this side by 200. That will cancel. And you must do the same to this side. So we'll times that by 200. So if you simplify, it will be 200 times the sine of 50 will give me that depth, will give me x. So if you go and put that in the calculator, you'll get, we are going to get 153. And let's pretend like the question said round off to 2 decimal places. I'll just round it off. So it would be 153,21 meters. Okay, guys, so that is how we look at the angle of elevation and depression, and how we use trigonometry to solve the questions. I hope that was helpful, guys. If you have any other questions, please don't hesitate to post. Yeah, I'll see you in the next one.